welcome to this joint webinar between Embedded Wizard and Variscite. Today we will go through the creation of a human-machine interface using the Embedded Wizard framework with Variscite evolution key. Today with us there is Manuel Melic, Product Manager, Embedded Wizard and Managing Director for Terra Systems, and me, Luigi Passero, that I'm the R&D software expert for Variscite. Let's go through the agenda. We will start talking about Variscite, and we will go through the Embedded Wizard framework. We will show you the demo on Varsome MX93. We will explain how to download the resources and contracts, and then we will have a quick question and answer session. Now let's start about Variscite. Variscite is a leading system and module designer and manufacturer since 2003. We are in the market of embedded products. We have over 7,000 customers worldwide with a production capability of more than 3,500 kilo units per year. We sales more than 2 million units every year, and we keep growing year over year. The local offices are in Europe and North America. We are compliant with the ISO standards, and we got related certification. Variscite is a leader in the ARM-based SOM market. We have an extensive customer base and pipeline. We provide a very diversified ARM-based portfolio with the extended longevity granted from the chip manufacturer, and we also provide compliance policies. We've been the very first SOM vendor in the NXP Platinum membership, and we are partner with NXP for MX8 and MX9 product lines. The internal production line, we have internal production line for a stable availability and solid lead time. Let's briefly talk about what is a system and module. Basically, what we provide is a module that integrates system on chip, the DDR, so the RAM, the eMMC for the outputting media. Optionally, we also provide Wi-Fi, audio codec, and the main features that you can find in our SOMs that we fully configured. We provide free of charge the embedded software that can be used to test the SOM itself, and we also provide the carrier already tested and the sheet and the schematics of this carrier are completely free, available for the customer in order to quickly go to the production. So when you start with the SOM, you can customize the SOM according to your need in terms of components like quantity of RAM, size of the eMMC, rather than having or not having the Wi-Fi, the Bluetooth, some other components on top of it, like the CAN controller for those specific SOMs rather than the touch controller for other. Being fully customizable, the customer has several degrees of freedom in order to get the product that better match his target. The advantages of using a SOM solution is to quickly reach the market because you start from a already tested hardware and software. You will experience reduced R&D cost because most of the software and the hardware is already pre-tested. So you just need to take care of the carrier and customize the carrier according to your need. You have full scalability and upgradable because of the pin-to-pin families. Variscite, and we will see in the next slides, provide a series of families that can allow to use the same carrier board with different SOMs. 100% yield all the time. All the hardware and software is production ready. You will get free support for the customer through the customer portal, GitHub, VariWiki, that is our documentation website. Tested all the SOMs in Carrier are already tested and used from hundreds, I would say thousands of customers. So there's a proven high reliability and a low risk. The in-house production grants stability over availability and lead time, and the long-term longevity is granted directly by the chip manufacturer. So this, for example, NXP, the longevity for NXP products is never below 15 years, at least when they start. In this session, we will focus specifically on the Variscite MX93. That is a SOM based on NXP dual-core MX93, which features a Cortex-A55 with a Cortex-M33. It integrates machine learning with an NPU of 0.5 TOPS. The memory is available up to 2 gigabytes, and the eMMC is available up to 128 gigabytes. There are 2 gigabit Ethernets, USB ports, 2 CAN buses, the camera input, audio, of course, granted through the Wolfson WM8904, and you have display output. In our evaluation kit, we provide an LVDS, a sample LVDS. The SOM itself comes with Murata Wi-Fi that is capable of also ZigBee optionally. The chip itself integrates to the accelerator for image stretching and translation. The industrial range granted the capability to work between -30 and 85 degrees, and the longevity is in the order of 10-15 years. Also, this SOM is part of the pin-to-pin family, but the same pin-to-pin family, a different pin-to-pin family introduced also the Dart MX8M Plus, that is actually a Cortex-A53 quad-core with Cortex-M7, another NPU that is able to reach 2.3 TOPS, image signal processing, much RAM is available here up to 8 gigabytes, the same amount of eMMC, 128 gigabytes, to Ethernet, a USB 3, CAN FD. Also in this case, we have camera inputs, in this case, actually 2 camera inputs, audio and display output. The same Wi-Fi is available also here. This chip integrates a Vivante 3D accelerator, so from a graphical perspective, you can run OpenGL. Same extended the range of temperature, same longevity, just a smaller form factor, because this is the Dart pin-to-pin family. Going into details of what is a Dart family, this is the list of SOMs that belong to this family. We are talking about Dart MX895, 93, 91, Dart MX8M, and MX8M Mini. We are talking about different system on chip from NXP with different power and different capability. For example, the 95, the 8M Plus, and the 8M, the 8M Mini have a graphical accelerator. The same chips from NXP also provide hardware decoding capability, but the encoding capability is only available for 95, 8M Plus, and 8M Mini. And now let's start with the session from Manuel.
Thank you very much, Pierluigi, for the pleasant introduction. As said, my name is Manuel. I'm responsible for our UI solution Embedded Wizard here at Hara Systems. In the next couple of minutes, I'd like to give you a brief background information about our software Embedded Wizard. And this will be the main focus now for today's webinar is I'll show you the workflow, the development workflow, how to get the first user interface up and running on the Variscite Vasom MX93 evaluation kit. But first, a couple of background information. As said, what is Embedded Wizard all about? In fact, Embedded Wizard, that's our solution from our company Taro Systems, we are headquartered here in Munich, which we're providing to the market since many years. Something which makes us special is that we are providing a source code generation model. So that means it's not just a pure graphics library that is being used with an API and you program against that API. No, in fact, everything is designed and implemented and tested and simulated and debugged and profiled on the PC within the Embedded Wizard Studio, something that you already see right now here on the right side, where a small screenshot is being presented. And the studio then analyzes, when generating the sources to your embedded system, which bitmaps, which fonts, which logic is being used, and optimizes and take everything into account, which makes the HMI coming to life. When we started with Embedded Wizard more than 22 years ago, the architecture that you found at that time, I think you believe in me, were less powerful in terms of CPU resources, in terms of RAM usage or RAM availability or memory availability in general. Of course, flash memory also taken into account. That you find nowadays in an MCU world, so Cortex M4, Cortex M7, or of course even in the MPU world, which we have right now. But our architecture didn't change ever since. So that means that the platforms that we addressed at that time, so more than 20 years ago, these we had to keep in mind that the UIs running on those platforms have to be very fast, have to be very performance, and because this is what our aim is. But coming up to the next years and have a steady growth and further development and evaluation of the product itself. This is something that keeps us scaling up with newer architectures and newer platforms. And coming from the consumer electronic domain, where we first started, in terms of TV sets and PVRs and set-top box and this kind of stuff, those also push us with new requirements in terms of to support MPUs, like having a GPU there and using that. And this is something that we are now offering since many years. So we are the only solution in the market that can really scale down to a very low end. And what means low end? We start with 16 kilobytes of RAM up to the very high end and even beyond that. But what I mean with beyond that, I will show you later on. So scalability is something which is essential for us. We're doing this since many years. As said, Embedded Wizard is not the first tool that we're providing to the market. It's meanwhile already the fourth evolution and generation that we're providing to the market. So we have a very deep knowledge and a very good expertise in this kind of domain in terms of graphical user interfaces from I would say from the beginning of our company, which is more than 30 years ago meanwhile. Also something which is special, at least from our perspective, we do not have any external dependencies. So that means there are no open source or any other third-party components built into our stack. And this gives us the full flexibility. That means if customer wants to have some new features, let's talk about that. Or if a customer has an issue, and we can exactly nail down where it happens. Maybe in the very low end, in order to or how we adapted and used the drivers up to the high end. So on the topmost part, which will be then the application, the studio where you create the user interface, we exactly know what's happening because we have the full control of every line of code inside our entire firmware and inside our entire framework at the end. And as said, this gives us flexibility, fast flexibility. We know what's happening, and this is something that our customers love absolutely. We're doing this not only here in Germany, of course, we're doing this worldwide. So we have a very worldwide customer base already from the beginning of our company. So big TV brands like Sony and Panasonic and so on, they already used also our software components. And this is something where we started, as said, with a global manner from the beginning, and were there from our company's beginning. And also not doing with 1 or 2 devices per year. No, millions of devices have been deployed using our technology. But what makes us special And what are now the benefits for our customers, and especially for those customers using the Variscite SOMS modules, for example? Well, the Embedded Wizard Studio, this is a full-featured IDE which gives engineers the possibility to really develop the HMIs, the GUIs at one place. So that means there's everything built in from of course the development, testing, prototyping, simulation, debugging, profiling, and so on and so forth, all in one place. And you do not need to change worlds from a designer to an editor. No, you only stay in one world, and this is very efficient, that you will see later on as well. When it comes to the performance, I think everyone believes me, because everyone has an. I think that everyone has a smartphone in his pocket, maybe iOS based, maybe Android based, and everyone is used to have high performance user interfaces. Of course, we all know that the mobile phones, the smartphones, are very powerful in terms of the CPU and RAM and so on. But a customer or the end user at the end is used to have this kind of performance, and this is something that of course drives us in order to make the GUI at the end also very high performance, while having in mind being lean, and only using those resources which are there, and not overload. So we are not greedy in terms of what we need to get from the other components, so that also your middleware stack, for example, has enough air to breathe. So this is something what makes us special as well. As said, smartphone-like GUIs, this is something that we have in mind, and of course we support animations and transitions and everything what is required in order to make a state-of-the-art user interface, of course. As said, we have a source code generation approach in mind. That means the user interface that's being developed on the PC is then being analyzed in terms of what bitmaps and what fonts and what strings and what logic is being used, and then generated to the selected target. And while selecting the target, only those components are then being transferred with the proper color format, for example, so that at the end only the user interface which is required is being stored on the embedded system. And because we do not have any dependencies to any other third-party components, the HMI stack is just one part, so it does not require any other things from the outside world. As already said as well, our requirements in terms of the available memory are also very low. 16K of RAM is needed in order to get an Embedded Wizard GUI up and running, with of course only the flash amount that is required. As far as I remember, it's something about 230 kilobytes of RAM of flash is being needed for the stack. So talking about an HMI running on an MPU, I think you believe me that these are not so highly demands in terms of the memory. Also in terms of requirements, what we do not need is any operating system. So there's no necessity to have an operating system up and running. No need for semaphores, for mutexes, and so on and so forth. But this also gives you high flexibility. You can use any operating system because we do not require any operating system, and UIs can also run bare metal, for example. Embedded Wizard is not an open source component. It's a proprietary stack, so that means we have dedicated a license model, but at least what I know and what we say and what also our customers say, of course, our business model behind is very reasonable. So just to give you an idea, as of now we do not charge any royalty fee per device, so it's different calculated, but we can talk about that later on. So this is just about the slideware. What I now like to do is just jump really into the workflow and development workflow, and I'd like to present you how Embedded Wizard is being used in order to create the very first user interface on the Variscite Vasom MX93 SOM module. So for that, I'm just now making this small, and of course get used to start the Embedded Wizard Studio. As said, this is the IDE to create the user interface on your PC, and what I'm now just like to do is create a new project. Then a template wizard pops up, and for that I'm just now using this one and filter it to Linux. In fact, the iDynamics 93 does not come with a dedicated GPU, which of course we are supporting in terms of using the OpenGL driver, for example. So then I would need to select that one. Example, to go ahead with iDynamics 8, for example. But anyway, now for the iDynamics 93 based MPU, we are using or relying on the pure software approach. But also worth to mention, it's not only pure software, we are also utilizing the ARM Neon SIMD instruction set. SIMD means that you have a single instruction, multiple data, in order to have some kind of boost for platforms running inside this Cortex-A architecture. So selecting there the software, I just leave the frame buffer format as is, so RGBA 888, so we have pure 32-bit. Then we can utilize in the best approach the ARM Neon instruction set. I need to define the screen width and height, which is 800 by 480 pixel, which is or which matches the display being attached into my evaluation board. And finally, I'd just like to mention the project name, which is now just webinar, and here we go. So let's create a new project, and then Embedded Wizard just creates a very first application which can be used as a starting point. So what you see is welcome to Embedded Wizard. That would be if we would now just generate the sources, compile it, and link to the and link the application and flash it to the device. This would be now the application that will be presented on the screen. How to verify if it's really that what you have in mind. Here in the middle you find a very small button, the play button, and this just starts the prototyper in order to simulate the user interface. So you see now the welcome to Embedded Wizard string, which is being presented at different positions, and the size, the color is changing while this effect is happening. Just a very brief idea. So how can this be done, or how is this being structured? So for that, I'm just removing that because I like to go ahead and start from scratch, and in a very plain way. I just need this white rectangle right now here in the background, and what I'm now doing, I'm selecting it. So it's being selected, and here on the right side inside the inspector, I'm just now changing the color from pure white to pure black. And when you now press again the play button, then you see I just have a very black rectangle. Perfect. No, it's not. So what now customers are doing is here on the left side in the gallery, they select different kind of, or they can just drag and drop different kind of elements like this bevel or image, and like a wallpaper, and change of course the screen, and have a text. And the same approach, selecting the text field, for example, you can also now scroll down here inside the inspector on the right side and change, for example, the string to be displayed, and I just say hello, and then it goes to hello. Or you can also select a different font. Now not this one, a little bit bigger font, and then you have it. So quite simple. And if you're happy, just again I said, press the play button, and then you see instantly the simulation of the currently user interface. So this is just very basic static elements. I said quite simple. With that having in mind, usually a user interface would not be very not very dynamic, because if you want to have something like or some dynamic parts, then usually you would add that. How to add that? Just go on the left side in the gallery, I said, and select here the folder effects. And what I'm now doing is just now drag and drop, for example, a color effect into this canvas here. And now you see, a speciality of Embedded Wizard. Our philosophy is that we want to draw things as often as good as possible. That means, for example, this white rectangular or the text string, the bitmaps, the line, etc. Those components can be, of course, rendered. It's clear that the text needs to be rendered in order to present the string. The rectangle with its color, or the bitmaps, depending on the bitmap resources. But when it comes to software development, there are also things that cannot be rendered. Think about a method, think about an enumeration, think about a class, think about a set, think about an object, something like that. Those components, of course, also need to be reflected somehow inside the project. And what we thought about is, let's stay in one world, so that you do not need to switch between different worlds. Like I said, designer and editor. No, it's just one place. And just render those non-renderable things, like a method, with these kind of bricks. Now every type inside Embedded Wizard may be a variable, maybe in this case now an object, so the instance of the class effects color effect is being represented as a brick. And now you have the benefit that you can also now group and sort the bricks according to your architecture, according to your software architecture. And with that in place in mind, you have the possibility to really focus where are now all my objects, where are now my methods, and so on. And you do not need to scroll and see where everything is being implemented. And yeah, as I said, you can now benefit also from things like grouping and sorting in a very visual way. Anyway, I just selected now the object right now. So the color effect, and in the same manner as I did before, on the right side, inside the inspector, I'm now changing parameters of that object. So for example, first would be inside this color effect, I would say, okay, it should be a symmetric effect, so it should run from one color to the other and then back again. Hence, I'm just now selecting it and changing it to true. Of course, I'm changing now the colors. That means it should go from a green color value down to a purple color value, for example. I also need to define the outlet, so that means on which kind of object should this color effect now being active. And I have here my black rectangular in the background, so I'm just selecting the rectangle color. And finally, so that the effect now knows which object should be changed. And finally, I just need to make it run, so that means I set the property enabled from false to true. And if I've now done everything in a proper way, pressing again the play button, now you should see how this color effect works on that black rectangular by changing the color from green to purple and back again, and so on and so forth. With those, so static elements and the dynamic elements, customers can create their own user interface. For example, like buttons and sliders and views in terms of lists and groups and so on and so forth. Tabs. And of course, this can now be done with Embedded Wizard as well. But for all the basic stuff, let me just now remove this. Oh, by the way, if that was a little bit too fast inside the color effect, what I have now done. Also worth to mention what we have built in, and there we spend a lot of effort into it, is to have a very sophisticated documentation out there. Sophisticated means when you now, for example, press here the F1 key on your keyboard, or the button here, the context sensitive help, the knowledge base of Embedded Wizard opens within your browser. And the fourth element is already related to the cursor that previously was set inside the studio. As you see, I've now selected, or which component has been selected. I selected the color effect, and it already gives me, after the first three basic or the common entries inside the knowledge base, gives me right direction to how to use the pulse color effect. When I now click on that, then you see what I have done. I drag and drop the element from the gallery from the left side into the canvas. I made it enabled, and I selected the outlet. That was the black rectangular. And finally, I think, and so you can scroll, you can change timings. We're now just using a very linear way, so also quite simple, but you see it's very well documented. Examples can be downloaded for different kind of effects and aspects. And when you're happy, then you can see how it's being used, and by changing just here now the value for the dedicated color at the end. So this is just to give you an idea how this documentation is built into the studio as well, and so that you have this always at your side in order to get things done as efficiently as possible. So just jumping back, this was just about the knowledge base. So as said, with the static elements like the rectangular and bitmaps and text and so on, and the dynamic elements like color effect, customers build their own user interfaces, buttons, sliders, and so on. But you do not need to reinvent the wheel, because there are a couple of, I think I need that one so you can see better. Just on removing the previously elements Here we go. And these typical elements, what you need for a UI, like a button, is already available inside Embedded Wizard, of course. So for example, there is a slider. You can change, of course, the position, and you can change the size of different sliders. I'm not sure if I said that before, but I studied computer science. So I'm a deep heart, I'm a software engineer. So please excuse my user interface designs. They are functional, but not really appealing. But so I hope that's okay for you. So anyway, so let's pick that one and change it. So just widgets, and what you see is now very black and white style. This is just due to the case that it does not follow a dedicated color scheme or dedicated appearance at the end. So every customer project is individual, is unique, and so we cannot reflect every customer requirements, design requirements. So, but it's just a base and doesn't follow any design, and you can change that. So for example, changing means you're selecting now this color effect here right now and changing here this appearance. For example, now we have this mono style, and there's another one, lime small, and you can see how it would now change immediately when you change this, or change dedicated items so they can see how it runs. And the big benefit is you can also, of course, create your own appearance objects. And this principle is something the same that you perhaps might know from HTML and CSS, where HTML is the structure and CSS defines how dedicated structure elements inside your HTML document are behaving. And this is the same principle. You have here the appearance object, and you can define that according to your needs. And when I have changed everything now to this style, then I'm already finished, more or less. Oh, this was medium, doesn't matter. So pressing on the play button, then now I have this wonderful color effect still running. Let me just switch it off. Pressing again the play button, and now you see that how these UI widgets are working. You can drag and drop these elements. Everyone is now acting for its own, so that means there are no connections made. You can press the button and so on and so forth. So you see instantly how this widget would work, and I said you can change the appearance, you can create your own appearance objects following your color theming and so on and so forth. And of course, also worth to mention, you can create your own widget. How to do that? Just to see the big picture, there you have inside the gallery the folder called component templates, and with that component template, let's for example take a push button. You see that right now. And by double clicking, it opens the implementation, and by pressing again the F5 key, start the prototype, you would see that it would now be just a very simple rectangular with just reacting on different kind of events. So that means also now hitting the enter key on my keyboard, which can be used to simulate hard buttons, for example. So this is a implementation of a push button without any functionality in terms of, or unique functionality according to your project, but gives you the flexibility to also adjust, for example, the behavior. Like inside the application with the ready-to-use widget sets that I just shown, these are working in a linear way, for example. But if you have, for example, the requirement to follow a logarithmic approach, then you would need to either adapt them, so you can fully adapt them, but you can also have the possibility, to implement your own. And with those templates, I said these are templates. As a starting base, you can then implement your own widget according to your needs. So this is just the next excerpt on that. Now I just want to stick onto the ready-to-use widgets, as these are more easy to understand right now when it's the first time you get ahead with Embedded Wizard. Anyway, as said, pressing again the play button, you see how the application is running. You can change the items, you can drag and drop the elements, push the button, and so on. Usually, those components reflects a dedicated property inside the system. A property is something that, of course, is also available inside Embedded Wizard, which is nothing else than a variable with setter and getter methods. So that means you have a property in terms of this is an integer 32 variable plus the dedicated setter and getter, which means that these methods are being called every time you're writing to that variable property or every time you're reading from that property. Let's change the name. It's not a property, it's, for example, I like to change a temperature, something like that. And as you see, also refactoring is built inside the Embedded Wizard Studio. So that means when you change here the name of the property, whatever not done, did to temperature, then all the references are being updated accordingly. Now I have this property. Now what I now like to use is all my components that I have right now, and those components should now react on my temperature variable or property, to be precise, in the same way as my color effect did now for the rectangle, and therefore I'm just now using this outlet and selecting my temperature. And what you now saw is that all the elements, as soon as I've selected this temperature property as the outlet, every component is being switched to 0 because that's the default value that this property has. But anyway, when I now have this application, and you can see when I'm just now dragging this element or that element, then you have this in the same way now listening and reacting on this variable temperature for all the components that I've made the proper connection with. So, and this is now, the easiest way in order to have a connection from the UI to the underlying system. How can this now be done, or to be really put onto the target? Well, first of all, let me just show how this onSet method, for example, is working, where you can now, for example, also add your individual content. So there's a small editor, because at the end it's a software engineering tool, so you need something like a software view on the components as well. And where I'm now just typing if my value is higher than 50, I have this wonderful still active color effect available, which I want to enable. And otherwise, if the value is lower than 50, then just set to false. Pressing again the play button, and what's now happening when you now reach 50, then it starts blinking. And when I'm selecting another, and it stops blinking and it starts blinking, and so on. Quite simple to see, quite simple to understand. However, if there's an issue now, if you mistype something and you want to debug, then there's also quite convenient way. I'm just now pressing F9 on my keyboard, which opens a red circle right now. Puts a circle here in line 9, which is nothing else than a breakpoint, and that means when I now press again the play button, then as soon as I'm not hitting these 50, then the breakpoint gets hit. I can have a look at all my local variables, my objects lurking around, identifying what things are being changed. I have, of course, also a call stack and all other core objects being available inside the current runtime. And I can do a single step into different aspects and see what's now happening in the system in order to analyze my user interface without the necessity to go to the target, to launch the debugger, go to the proper thing where things, or to the place where something is not working as expecting. And this is also a big plus in terms of boosting the efficiency. So this onSet temperature, for example, the method that's being called, that was the first thing that I said before, would also now place where you could now define to go to the target. That means you can now here use your system API, your middleware API, but I do not want to spend so much time on that. This is well documented on our knowledge base as well. There are dedicated videos out there. I'll show you links later how this works. But anyway, that would be a place. Also worth mentioning, to mix now the views and a middleware component into one view is something which is, from a software architectural point of view, not the best approach. It's just now for simplicity, so that you can see how things are being connected. Usually our suggestion or our recommendation would be really to separate things. You have the implementation of the UI, you have the implementation of the binding to your underlying middleware, and you have a dedicated separations of concern, how it is called, and this would give a proper architecture. Also, some words about talking to the target. Something what new customers often ask me: how do I now have this API, and how can I bring this into Embedded Wizard, or where do I find the callback to implement according to my API? And well, the answer is on the one side quite simple. There is no ready-to-use API inside Embedded Wizard. There is no ready-to-use callback to fill in with your API calls from Embedded Wizard's point of view, because every customer is unique, and every HMI is unique, and every product at the end from our customers are unique and individual. That means the middleware which is available can be a very simple one. It can be with just 3, 4, 5 API calls, a very lean one, or it can also be very big with asynchronous mode and with a very, very deep and detailed interface. Everything is possible. There's just one thing you have to keep in mind, that Embedded Wizard can use any APIs, so maybe synchronous, asynchronous, push-pulling, message-based, whatsoever. But you need to first define the API according to your middleware, to your business logic, inside Embedded Wizard before using it, because there is no one. This is for the first time a little bit a struggle, because you do not immediately see how it's being done. And for those, in order to give you proper entry point into the system, there's also something like a widget. It's the so-called device interface, where you can have a first get to know how things are being used inside, or how to define your own API inside of the binding from the HMI world, from the Embedded Wizard world to your middleware asset, and this would be here now the place. But anyway, this is also well documented asset inside our knowledge base, and I just do not want to spend so much time on that. But something worth to mention when using the prototype or the simulation of Embedded Wizard, you can also go to window and have a look about the currently used RAM amount. So that means, there's the breakpoint. I'm sorry for that. Just removing that. Press F5 again. So, for example, when you're now changing and do something, then you have an instant view on how much the current GUI is being used inside your system without the need to go to the embedded targets. So you have an instant view that this currently user interface is taking care, or takes 256 kilobytes of RAM, which is just a rough estimation, but it already gives you a proper feeling if you made everything as expected. It also gives you about configuration, a recommendation about the configuration of the system itself, but this would be now too much detail. Anyway, so you can also profile the user interface while developing the user interface on the PC without invoking other tools. Now let's go to the target. Selecting now the project, selecting the profile. As you probably might remember, Embedded Wizard follows a source code generation approach. That means I now need to define the output directory where the user interface is should be being generated. Therefore, selecting now the 3 dots, and I just have prepared something which is our so-called build environment. The build environment, what we have prepared now for the SOM module right now, is a starting point. It's our reference setup and environment for customers to get a very first user interface up and running. It comes with a couple of examples. It comes with the so-called master demo, which is the combination of multiple examples into one binary ready to being executed on the system. We have the so-called platform package, which is the abstraction layer to the used system, where, for example, touch is being analyzed, where all the graphical operations are being defined according to the platform, or of course depending on the selected platform. And this is something that changes from the MCU world to the MPU world, and there we have more than, I think, 70-80 different platforms meanwhile supported. Target specific, this is really specific to the selected target. In that case, for the Variscite Varsum MX93 platform, for example, how to adapt the touch drivers and so on. Inside the application, there you find project, which is makefile here in this Linux world, where you also some static code is being there. So in fact, this is the main C, or being selected the main C, and there you also find a folder called generated code, and this is now the folder where I like to select this within the studio, where now the Embedded Wizard Studio puts now all the generated C and H file into it. So that means pressing now this button here inside my menu bar, the small crank symbol, invokes now the Embedded Wizard Studio to analyze the GUI project. That means bitmaps, fonts, strings, the logic is being analyzed, and C source code is being generated. Remember, we had that, I'm pressing F5, control. We have here this memory usage window for the RAM usage, but now you might ask, what about the flash usage? There we're also generating during compile time or during generation time a short build report, which gives you the idea that the currently amount of generated sources and the estimated flash usage is roughly about 215K. I see it's quite small, but it's also not a big application. You can jump into that and you see, okay, where are now the most things being used and so on, gives you a good feeling instantly how your system is being structured, how your system, the GUI application, is being set up when generating the sources. Anyway, I have now generated the sources into that folder. Now I would need to execute it, which means I need now a cross compiler. I have here my Windows machine. There I have installed the Windows subsystem for Linux. Quite simple. I need to go now to this build environment, our SDK, in fact, that I have. No, sorry, on C. Variscite, and there we have, hold on, no, what's not happening? So this is, here we go. So there we have the Variscite, and we have the application, and we have the project, and just now, hold on, start again, and now I need to invoke the cross compiler. As said, I've installed for Variscite my cross compiler, my toolchain, into this folder right now. Sorry, missed something, because I need to make it clean again. I need first to use my toolchain and set the proper environment. This is something I forgot, sorry for that. Just now going back. So I've now sourced the environment setup so that the system now finds my cross compiler, and now I just invoke make, and my generated sources, source code is being compiled, plus the static one, as said, the main C, for example. And what's now happening, and this is not nice to have, let me just make it clean again and regenerate the sources. Not regenerate, compile again. I think it was just due to previously wrong set environment variables in my system. Here we go. Okay, so now everything is being compiled. Now I want to go to the target, which means first let me just show it to you. I have here prepared a small webcam, and let's go here to full screen. So I said this one is here now the Variscite SOM module, the baseboard, plus the attached display. As you see, no Embedded Wizard application is running right now. It's just the Wayne & Weston setup, which comes out of the box. But this is something now I need to stop. So therefore, I have set up my console. Where is my console coming out? Hold on. Here we go. So just logging in, and for that I'm just now stop my Western service, and now it's being black. Display is still up and running, but it's not being there. I have now my compiled application, Embedded Wizard Linux DRM, and this is now something I need to copy that. We have prepared a small script which just executes, which copies the application to the system and executes it via OpenSSH. So, and this is something I'm just now invoking with make install. And what you now see inside the web application, that now our previously being generated UI is now up and running in the same way as it runs on the target. So that in the prototype. So that means every time I'm now hitting the 50 value, the effect starts and stop, and so on and so forth. And doesn't matter which one I'm now choosing. As you see, it was the same way that we have here inside this application. So just hitting again the play button. You see the same behavior which is running here right now is running in the same way now on this embedded device. Quite simple. Something that I also like mention and show you in last couple of minutes. The source code generation model means that we can not only generate the sources for an embedded system in terms of ANSI C and H files, we can also generate different sources. So that means I'm not just now copying this profile right now from profile and renaming it to web, which means we can also generate applications for the web world, which requires to select a different platform package, which would be now my WebGL platform package. I'm just now using a different folder, not generated code. I would just type in here web, and by now selecting a new profile inside this menu bar and regenerating the sources, Embedded Wizard now follows the same process, means analyzing the bitmaps and strings and so on and so forth. And as soon as I've generated everything in a proper way, we also have now a new folder, which means application web, where now HTML and JavaScript files are being generated. Now I have a web application, which means I also need something like a web server. Let's just go here and go to the new folder web. Let's just use Python and start a small web server. And here we go. Come on. So I have my web server running, serving now my components and opening now the web application, and just use now the same application inside my entire web browser, which has the big benefit now to offload the CPU, because now the UI is being rendered entirely inside the web browser. Something, just two use cases which are the commonly used one. Think about sharing the current development of the user interface to other stakeholders. Just copy the generated sources to a web server and publish the URL to anyone who needs to have a look at it in order to get a brief information of the user interfaces during development time. Or you can also, of course, let the generated sources being stored on the embedded device and let them then provide the application in terms of a remote user interface, where you can then control, of course, the local HMI now via web. So this is a quite nice and convenient way. I just want to show you that. Okay, so this is now just for the presentation on how to get started inside Embedded or with Embedded Wizard on the Variscite submodules. Just jumping back into the slides, I'd just like to present you where you can get started and where you can download it. First of all, we have the website embeddedwizard.de, and in order to get started, just go to the download page, which you can find, of course, here inside the menu download. Type in your name and select here as the platform the Varsom MX93 dev kit, for example. Type in the foam, and then you can download Embedded Wizard, the Studio, the free edition, which I'm also now using right now, which does not come with any restrictions in terms of time or in terms of features. It's only limited in terms of complexities. So that means as soon as there are too many strings, too many bitmaps, and so on, the studio would say, okay, now it smells like a real commercial project, and then you cannot generate or save the project anymore. Good. Something else worth to mention. Go to download or just jump into the knowledge base we had before. Where is it? Is it? Here we go. No, come on. Oh no, this one. This is the wrong one. Let's just do this one. So doc embedded wizard.de. Inside build environments, this is something also worth to mention if you want to get started. And this would also now the link you will being presented when downloading the Embedded Wizard Studio Free, which now just scroll down a little bit. There you can find the Variscite RMX93 software DRM component, and this describes in a very detailed way what things are required in order to get started. That of course needs some hardware components, some software components, where you can download it, download the build environment, our SDK, what I mentioned, what to prepare, and then at the end it also explains what is built inside this SDK, our build environment, and how to get your first application up and running inside your EDK, like I showed you a couple of minutes before. Well, that's it for my webinar.
Let me close the webinar just pointing you to our links. You can reach us through the website, variscite.com, through our sales, through the customer portal, and you will find all the documentation about the BSPs, what we provide for each SOM in variscite.com, and you can find all the code because we publish everything. We have no lost code in GitHub Variscite. Thanks for joining. Hope to see you to the next webinar. Bye bye.